Welcome to this presentation by Webel IT Australia on a proposal for a new element for UML and SysML, the logical wrapper. The logical wrapper offers flexible logical and graphical grouping of all elements for which graphical symbols exist and can be used in any diagram kind. Let's examine quickly the main features of the proposed logical wrapper. It groups elements logically in the underlying model and graphically in diagrams according to a context indicated by the wrapper's name, with traceability of the logical members of the grouping. Graphical containment of element symbols by the rectangular symbol for a logical wrapper in diagrams implies logical membership, grouping, of the elements represented by those symbols, but it does not imply ownership or containment in the underlying model. Any element that may be a logical member of a logical wrapper may be a member of more than one logical wrapper, and logical wrappers may be nested. By its very nature, the logical wrapper has special rules concerning ownership. A logical wrapper may never own an element that is not a logical wrapper. In this sense, the logical wrapper is described as parasitic because it never participates in the physical packaging of elements that are not wrappers. The logical wrapper thus offers organization of its logical members in a fashion that is orthogonal to physical containment packaging. However, whether a logical wrapper may own another child logical wrapper, not just nest it, is considered a variation point of this proposal, as ultimately the management of such ownership would involve tool behavior. No UML or SysML tool currently offers the logical wrapper. The examples presented here were in part created by annotating diagrams after exporting them from the MagicDraw tool. Now, in some cases, this involves reappropriation of the UML2 component. The realizations compartment becomes the members compartment of the logical wrapper, and the logical wrapper has a distinct wrapping compartment. So, to be absolutely clear, while the UML2 component actually does serve well as a logical wrapper for certain kinds of elements, and I have been using this device with great effect for many years, I'm not for a second advocating its long-term use. The UML2 component is in any case not supported in SysML. It does, however, give us a feel for some of the graphical and logical wrapping capabilities that a logical wrapper might have. The primary example we'll explore is going to involve some telescopes. Some are ground-based, some are space-based, some are infrared telescopes, some are optical. Some are based in Spain, some are based in the USA, and so forth. So we have different degrees, different axes for organization. Now, a typical approach adopted by less experienced modelers is to start with some kind of physical containment packaging and organizing them according to physical packages or models. It's enticing because you have also some graphical capabilities there. You have, for example, organization of all optical telescopes in the optical package. And if you move the package in the diagram, they all move together. However, this approach is very fragile. Now, before we look at why I advocate a logical first modeling approach over this physical containment type diagramming approach, I'll just point out why I'm displaying things in the diagrams the way I am with some redundancy to help us track ownership and the categories of the different elements. So, for example, In the optical package, you can see that I'm in fact also showing the ownership of the elements to make it clear that they are within telescope.optical currently. The same for the infrared elements in the infrared package. I've additionally also got some category stereotypes for optical elements and infrared elements. These will help us track the different elements independent of their physical packaging as we explore logically grouping them. I assert that using package or model for graphical containment in diagrams is notoriously fragile. If you change the packaging of any of these elements elsewhere, such as in another diagram, this diagram here breaks. Now, while package and model do offer some graphical grouping power, they are not well suited to analysis. There is a better way, and that better way is to use logical graphical grouping. In this example of use of logical wrappers, the same telescope elements have been organized according to whether they are ground-based or space-based. The wrap blocks happen to be packaged according to whether they are optical or infrared, but that's not important from the point of view of this logical wrapping. It plays no role. We can see also that some of the optical telescopes are ground-based and some are space-based. Some of the infrared telescopes are ground-based and some are space-based. Let's have a look at one of the problems that LogicalWrapper helps us address. We have here our physical containment packaging of some optical telescopes. That's very nice. You can move that around there. So you've got some graphical grouping as well. Over here, we've got our grouping according to whether the telescopes are ground-based. Now, normally you wouldn't do this in a single diagram. You would have this in one diagram, this maybe in another, and here you would be playing with the ownership in another diagram. But we're doing it in one diagram so we can see the effect all at once. Okay, so this telescope, the Gran Telescopia Canarias, I'm going to assume is Spanish. It's in fact not just Spanish, it's part of a consortium, but for the sake of demonstration, we are going to move it from the optical package into the Spanish package and see what happens. So we have the indicators of the ownership underneath to help us track. Let's watch what happens in the MagicDraw tool. Let's make some space. 1, 2, 3. Kaboom. The validation engine fires and tells us that this is now broken. But here we're okay. Telescope.Spanish. Now you may have noticed that I also have this representation of the model element here for optical with just the elements listed. You can see that it does not break, and I strongly recommend that you use this approach. Reserve packages for listing the elements that they own, and with LogicalWrapper we have another way of performing our graphical grouping. It's important to note that the LogicalWrapper is not just for classifiers. It's not just for class diagrams in UML or block definition diagrams in SysML. It's for any kind of diagram that has element symbols. In this example, we have a SysML internal block diagram for a motorized Newtonian reflecting telescope. There are wrappers that collect part properties and value properties for aspects that are optical, such as an eyepiece, secondary mirror and primary mirror, and aspects that are electrical, such as the power source, drive motor, or voltage. The logical grouping and graphical grouping is completely parasitic. It does not influence the underlying model at all. These are the elements that a logical wrapper could wrap in a UML class diagram. Note that it can wrap far more element types than a UML component. The extension to SysML is considered obvious. For example, data type becomes value type, class becomes block. The diagramming power that nesting logical wrappers affords is nothing short of extraordinary. It is compelling, and it's one of the major reasons for this proposal. I've been using for years the UML2 component for recursive graphical nesting and organization of diagrams with great effect. It is, quite simply, the very thing described in the Parable of Two Watchmakers by Nobel Prize winner Herbert Simon. Here's a very simple example of nesting of logical wrappers. We've grouped ground-based telescopes, space-based telescopes, and some airborne telescopes, and then we've grouped them in a wrapper according to the telescope deployment type. We can then use that higher wrapper itself in a higher logical nesting context. There is no automatic layout mechanism in any UML or SysML tool that can touch this for sheer graphical and organizational power, because it comes along with a workflow, and it also communicates to readers of the diagrams in a way that automatic layouts cannot, because it's organizing elements according to concepts, according to categories. The logical members of a logical wrapper could be optionally listed in a members compartment. Whether a hard compartment separator is used between the members compartment and the compartment for graphical grouping of logical members is considered a variation point. An alternative might be to show the members as tagged values in the same fashion as is often done for the SysML element group. The SysML element group has useful capabilities for tracking logical groupings of most element kinds, so it is very useful for traceable elicitation of model elements from text extracts using parsing analysis. It completely lacks, however, the graphical containment and nesting capabilities of the proposed logical wrapper, and it is also not relatable. We will, however, very briefly look at the relative strengths and weaknesses of the two elements. Please note that the following parsing analysis examples are greatly simplified. In the actual Webel recipe, the SysML element group is extended to introduce additional properties for tracking the source document from which text snippets are extracted. Similarly, the logical wrapper can be extended to support parsing analysis. In this example, the SysML element group is used for elicitation of model elements from the famous pangram, "The quick brown fox jumps over the lazy dog," using parsing analysis. We've managed to elicit some blocks, some references, some value properties, an operation, some SysML enumeration value types, and some enumeration literals. We also have a named association, some instances, and we're able to create a small scenario using a block so that we see a dog connected to a fox and the fox jumps over the dog. The state of the fox and dog are set using those value properties. Now there's no graphical grouping here, containment by the element group. However, in the parsing analysis strategy I promote, these kinds of elicitation diagrams are not presentation diagrams anyway, and the actual layout in these diagrams is not relevant. The elements end up being used in other end diagrams. Now, if you try to use a logical wrapper for elicitation of model elements from the same pangram in a single block definition diagram, you don't get so far, because you can't, in that type of diagram, represent as contained within the wrapper in any sensible way a sufficient range of elements. So for this particular application, in most cases, the element group is superior. A key part of the proposal is the introduction of a wraps relationship for tracking membership of logical members where there is no graphical containment. This is described here as unwrapping the wrapper. In the example here, we see that the space-based wrapper wraps 3 different blocks representing different types of telescopes. It is itself wrapped by a wrapper telescope deployment types, which also has some other members not shown. Logical wrappers are relatable. This is an extremely powerful feature. In this less than serious example, I've chosen to create a custom stereotype contradicts, and for no particular reason, I've chosen an abstraction as the relationship. So we see that a quote in one wrapper is claimed to contradict the quote in another wrapper. Now this example happens, again, to involve parsing analysis, but the mechanism can in fact be used for a huge range of different tasks in software engineering and systems engineering. The following shows a subtle problem that can arise when using relationships between logical wrappers. We might wish to indicate that space-based telescopes, ground-based telescopes, and airborne telescopes all complement each other. However, if we use dependencies, we have a maintenance problem. We're in fact breaking a single source of truth because we have 2 dependencies and each is then stereotyped, in this case with complements. However, it's not intended that wrappers should participate in association relationships, because that would require the logical wrapper to be a type, which would greatly complicate its specification. That ends the main presentation about the proposed properties of the logical wrapper element. If you wish to continue, there are some appendices with some explorations of some tool-specific issues. It's time to take a walk on the wild side and indeed use the UML2 component. Yes, I know that it's not allowed in SysML. And yes, I know that it makes your project file incompatible between tools. Either you are a MagicDraw Cameo Systems Modeler tool user and you will never care about interchange between your project file and another tool, or you already know exactly what you are doing. So I'm talking to those people who do not care. You are going to be able to save your file. You're going to be able to have UML2 components alongside SysML components, and you're going to be able to do it for many decades to come, I expect. Okay, so the first thing you may be wondering, if you want to explore using UML2 components as logical wrappers in a SysML project in MagicDraw or Cameo, is how you get the components in there. I've got here a little scratch diagram. I'm using the split diagram mode. I have behind the scenes here a wrapper stereotype component. Now, to be clear, this approach has limits. There's only certain kinds of elements that you can logically wrap with a component. But let's have a look at the kind of thing you can do in a BDD. All right, so here I go to my scratch diagram first. You can have the scratch diagram local to your SysML package. I've got it elsewhere, so we'll have to move the wrapper between packages once we've created it. So let's call this demo, and I apply the stereotype wrapper. Okay, I can now copy it from that diagram to that diagram. Now, if we look at it in the containment tree, I've actually got it at the top level here. Let's put it into the same area that we're working here. So there's my BDD elsewhere, and I can now start plonking things in. So let's give it a bit of context. Let's say it was, we might, to make it a bit better, I usually use lowercase to make it clear that it's a wrapper. I find using lowercase here better so you don't confuse it with a block. And the thing you might have wrapped might be, I'll say powertrain. All right, something to do with electricity. All right, so it's a basic idea. You want a value type here. Voltage. You probably wouldn't create your own one for that, but there you go. All right, we're off and running. Now, the traceability with members, if you've seen the main presentation, you probably realize that this is what I'm doing. I'm, in fact, taking that compartment and just annotating it with members. All right. I cannot begin to tell you how powerful this trick is. It's not a trick. It's a systematic systems engineering approach. It really, really works. Okay, so let's explore another aspect. If I take another component, have to do the same game here. I'll just call it, I'll just call it sub for the moment. I haven't got a good idea for what to call it. Okay, we'll do the same thing again. I know it's not ideal, but eventually when the logical wrapper comes along, we won't have to do all of that. Stick him in there. Now, here's the thing I want you to watch really carefully. If I go to owner, put the owner below there, this is a UML2 component. This is a UML2 component. I'll do the same here just so you can see that they're in fact currently at the same level. If we look in the browser over here, let me just do this slowly, you'll see that I've actually got my two wrappers, electrical and sub, owned by the same model elsewhere. Okay, so I can put that in there and note that I'm moving it in the tool. Now, specifications, like UML and SysML specification, do not usually concern themselves with how you move something in a diagram. What I'm showing you here is how to get work done. Okay, so the ownership of that has not changed. Now, when I talk in the main presentation about it being a variation point, whether a wrapper can own another wrapper, this is what I'm talking about, because there's a subtlety here. If I go into the browser, the model browser, I can in fact move this guy. So watch carefully. The owner has changed. So let's look at exactly what happened. When I moved it in the diagram, the outer wrapper did not steal ownership. When I moved it in the model tree, in the Explorer, in the model browser on the left, containment browser, it did steal ownership. So the graphical containment of this element does not tell us whether or not it's owned in this tool. We're now going to see how I've been using the reappropriated UML2 component in the MagicDraw tool for organization of diagrams using graphical containment and nesting in combination with logical wrapping. So these are our reappropriated UML2 components. I've got, to get started, some blocks here. There could be anything. I'll make some up as we go along. The wrappers have auto size on. Here we go. So they are alpha. They are numeric. They are alpha. numeric. You see, I'm dealing with concepts, not with packages. Right, they are symbols. Coming together pretty quickly. Let's make a math symbol. I will use a block again, I guess. Doesn't really matter. Moment, pi. All right, we've got a math symbol in there. You can actually, it's quite forgiving. If you don't want the stereotype on, the wrapper stereotype will get a bit more room. All right, let's try some others. Now, what I'll do is just quickly plonk any old thing in these others. I won't try and give them any meaning. So we can have one of the view, I for interface, so forth. You go together. I'm not going to try and put any meaning on this because what I want to show you is how I get the graphical containment. So you can see as I get it together, this is what I mean about the parable of the two watchmakers. As I get it together, I'm getting these little machines built that I can then put inside each other. So I'll put, so you two, put you in there. What I might do is then put you there. On the others, at the moment I'm just going to put them inside. I won't put anything inside these ones. All right, so here's your idea of your basic grid. They would normally contain something, little elements. Like that, like that, like that, something. You can actually do layouts inside there, but we usually don't need them. Let me get you out of the way. All right, so there's your idea of gridding. And no, something like that. Actually, I might put another one in there. Looks good. Kaboom, kaboom. So normally they would have some kind of coherent meaning, and there you go. Now, there is no layout engine that is going to beat it. There's no layout engine that's going to give it meaning. Okay, but I'm going to show you another trick. Let's say this one has some meaning. But this one, I'm just going to use as a graphical device. All right. This is the grid. So I'll show you another trick. If I get this and that one, and now you can either just completely hide the stereotypes or make the pen color white. See, this is the art and science of UML and SysML. I can either make the stereotype white or I can hide it altogether. What am I doing here? Oh God, lost that show stereotypes. Let's get rid of them altogether. Do not display. Make sure auto size is on. It is. And look what I've got. Aha! I have a hidden grid. Yes. These are the tricks. So, that's how I've been doing it all these years. And I have been doing it for all these years because it has been an extremely powerful technique for software engineering and systems engineering for all these years. And when we have the logical wrapper, we'll be able to do it with a heap of different types of elements in all types of diagrams. You can explore the basic mechanism of unwrapping a logical wrapper by using a reappropriated UML2 component in the MagicDraw or Cameo tools. Beware, however, that the graphical direction sense of the component realization relationship is opposite to the proposed wraps relationship for a logical wrapper.